This video is about arithmetic shifts, specifically multiplying using negative numbers or minus numbers. So I've grouped arithmetic shifts and logical shifts together because they both perform similar functions. They both allow you to multiply a binary number, like for example 1, 1, 0, 1, 1, 0, 0, 0. They both allow you to multiply a binary number by any of these numbers: 2, 4, 8, 16, 32, 64, and so on. And what are these numbers specifically? Well, you can tell that they are all powers, of 2. So for example, 2 times 2 times 2 times 2, 1, 2, 3, 4. 2 times 2 is 4, 2 4s are 8, and 2 8s is 16. So 2 to the 4 is 16. So arithmetic shifts and logical shifts allow you to multiply a binary number, in this case a minus binary number, by powers of 2. And that's it. So why have two systems that perform the same thing? Well, arithmetic shifts allow you to do this with signed numbers, and logical shifts with unsigned numbers. And if you don't know the difference between that, please watch my video on that. You also will need to watch a video or have an understanding of 2's complement and know that this binary number using the 2's complement system is a negative number. So let's have a look at this. So let's say you're taking that binary number and you want to multiply it by a power of 2. Let's say 2 to the 1. So how do you do that using arithmetic shift? First step is you write out the place values, and then you recognize that this is telling you how many places to shift by, and this multiplication sign is telling you that it is a left shift. So, and then the next step is drop down the MSB, the most significant bit. And if you don't know what that means, you need to watch my video on that as well. So step number 1, drop down the MSB. Then step number 2, left shift the values by 1 place. So I shift that 1 there and it kind of disappears behind the MSB. This one I'm going to shift 1 place to there. This one I'm going to shift 1 place to there. And then everything else is zeros. So what do we have? Well, we've got this binary multiplied by 2 to 1, which is 2. This binary multiplied by 2 should equal this binary. Okay, well, how do we know this was right? Well, let's figure out what the blue binary was in the first place. To do that, I'm just going to do it very quickly with the 2's complement. So my MSB tells me that it was minus 128. Then I got a 64. Then I got a 16. Then I got an 8. So I'll quickly add these together. 6 and 4 is 10, that's 18. Carry the 1, 6, 7, 8. Then I'll take it away from my minus 128. 88, which is, that's 0. That I can't do, so I'll make that to 12. And that is 4. So this is minus 40. Okay, the blue binary, converting it using the 2's complement system, tells me that actually it was minus 40. So I'm doing minus 40 times 2. Well, minus 40 times 2 is minus 80. So hopefully this orange binary is minus 80. And I'm going to do the same method to see if it is in fact minus 80. Here we go. So I've got my minus 128. I've got a 32. And I've got a 16. Add those together. That's 8. 3 1 is 4. So I've got 48. Minus 128 minus the 48. Let's see. That's 0. 2 minus 4, I can't do that. That's 12. And that's 8. So the orange binary is minus 80. So let's just recap it one more time. Arithmetic shifts allow me to multiply a binary number by a power of 2. I'm multiplying this blue binary number by 2. The blue binary number is actually minus 40, so I'm doing minus 40 times 2. Minus 40 times 2 is minus 80. I perform the arithmetic shift using the orange there, and I calculate it back, and I do in fact get minus 80. So that's worked. Let's do another one. Let's go with 11100111. Let's say that I want to multiply it, I don't know, by 2 to the, let's say 4. I want to multiply it by 4. Okay, using the arithmetic shift multiply. So clearly using 2's complement, I can see that this is a negative number, but I don't know what it is. It's negative something. Well, let's find out. So I got a minus 128 there. That is a 64. That is a 32. And those added together are actually 7. Let's see. So 7 plus 4 is 11, plus 2 is 13. 6 plus 3 is 9, plus another one is 10. So I get 103. Minus 128, take away the 103. So I got 8, take away 3 is 5. 2 take away nothing, well that drops to 2. 1 take away 1 is 0, so 25. So this is minus 25. Okay, using the 2's complement system, I've quickly worked out that that binary is minus 25. And I'm multiplying it by 4. Okay, so how do I do that? So step number 1, write out the place values. Well, 4, I need to convert that to a power so that I can find out how many shifts I need to do. And the multiplication tells me I have to do a left shift. So here we go. Step number 1, drop down the MSB. That stays because it tells me that the answer is going to be a minus number. And now I'm shifting everything by 2. So this one, 1, 2, there. This one, 1, 2, there. This one, 1, 2, there. This 0, 1, 2, there. This 0, 1, 2, there. And I fill in these empty place values with zeros. So minus 25 times 4, hopefully, well, it is in fact minus 100. So hopefully this binary is minus 100. Well, let's find out using the 2's complement system. Well, I got minus 128 there, and I've got a, what's that, a 16, and I've got an 8, and I've got a 4. Let's add those up. 6 and 4 is 10, plus the 8 is 18, 1 and 1 is 2. Minus 128, minus 128, take away the 28, well that's quite easy, gives me minus 100. So the answer in orange is minus 100. So minus 25 times 4 is minus 100. I perform the shift and I do in fact get the answer, which is minus 100. And that's it. That is how you perform an arithmetic shift, specifically with multiplication and specifically on a minus number, using the 2's complement system. Okay, so have a go at these. Let's say 1, 1, 1, 1, 0, 1, 1, 0, and you want to multiply that by 8. And another one, 1, 1, 0, 1, 0, 1, 1, 0, and you want to multiply that by 2 to the 1. Okay, so grab a pen and paper, press pause, and have a go at these. Okay, well here comes the answers. Well, I know that actually this binary up here is minus 10. And I multiply it by 8, but I need to express that as a power, which is 2 times 2 of 4, 2 times 4 of 8, so 2 to the 3, 1, 2, 3, yep, 2 to the 3. So that's my shift value. So I need to shift everything, multiply means left shift. So let's write the place values, 2, 3, 4, 1, 2, 3, 4. So I'm left shifting everything by 3 spaces, okay? So that goes 1, 2, 3, so I'll put my 0 there. That one goes 1, 2, 3. This one, 1, 2, 3. This 0, 1, 2, 3, and obviously I should have dropped down my MSB. I've got empty place values, so I drop them in. So what have I done here? Minus 10 times 8, well that should be minus 80. Does this add up to minus 80? Well, let's have a look. So I've got a minus 128. 128. I've also got, what's that, a 32. And I got a 16. And that's it. 32 plus 16, that's 8, that's 4. So minus 128. Take away this 48. That's 0. I can't do that. So it becomes 12. And that becomes 80. So the orange values using the 2's complement system add up to minus 80. Is that correct? Yeah. The blue binary, minus 10 times 8 is minus 80. And the orange after the shift is minus 80. Let's have a go at this one now. So, step number 1, write out the place values, 1, 2, 3, 4, 1, 2, 3, 4. And there's my shift value, I don't have to do anything with that. And I'm left shifting. Okay, by how many? 1. Okay, so step number 1, drop down my MSB, and then left shift by 1. So that 0 goes there, that 1 goes there, that 0 goes there, that 1 goes there, that 1 goes there, that 0 goes there, and fill that in with a 0. Well, what is this blue binary to begin with? Well, I know that it is minus 42, and you can check that using the 2's complement system. So minus 42 times 2 to the 1, well, what's 2 to the 1? That's 2. Minus 42 times 2 was obviously minus 84. So is this the binary for minus 84? Well, as always, let's check it using the 2's complement system. Alright, so let's add these up. I've got a minus 128, that's fine. Then I've got, I don't have a 64, I've got a 32, and I've got an 8, and I got a 4. Let's add those together. So 8 plus 2 is 10, that's 14. Carry the 1, 3 plus 1 is 4, so I've got 44. So now 128 minus the 44. So I've got 8 minus the 4 is 4. Can't do that. That becomes 12, 6, 6, that's 8. And there's my answer, minus 84. So my orange binary is minus 84. So where was I? The blue binary is minus 42 multiplied by 2 to the 1, which is 2, minus 42 times 2 is minus 84. I performed the arithmetic shift and I got minus 84, so that's correct.